this is the setup for bioassay for BTI. As you can see here, we have test material. It's a 37.4% water dispersible granules, or 3000 ITU per milligram water dispersible granule. You can of course use other materials like a 1200 ITU per milligram of aqueous suspension, even technical powder with anywhere from 7,000 to 10,000 ITU per milligram. Those are three materials we can use for BTI bioassay. Then, of course, the mosquito larvae of your interest or your concern. For practice purpose, the easy start, you can use the mosquito larvae from your laboratory colony, which you have a better control for the biofitness, their instars, and other factors. Of course, you can also bioassay the larvae of unknown, basically from the field or from any other source you want to find out their susceptibility to BTI. And then what you need to do is to make your material the serial dilution. For example, today we're going to use this 3000 ITU per milligram water dispersible granule, or WDG. You would start from 1% and then dilute to 0.1%, then 0.01%, and then 0.001%. So making 1%, I normally use 200 milligrams in 20 ml. And then make it easier is first vial I add 20 ml water, then the second, the third, and the fourth I add 18 ml of water. After I add 200 milligrams of WDG to the first vial, which is 20 ml volume, you shake it really well, make it well suspended. Then you take 2 ml down to the second one, then mix well, then 2 ml to the third one, and 2 ml transfer to the fourth one. And the fourth one is the one you're going to use for your treatment. Of course, every time you do this, you need to change new pipette tips to make your clean dilution. So this is the general rule for 10 times dilution, even though sometimes adjustment is needed in terms of your starting volume or ending volume, depending on your individual test, can be different, but generally most of the time you use this. Then, as you can see from the cups, there are 4 with different concentrations, and there's one untreated control. So this one labeled as UTC, stands for untreated control. Then you have a different concentration. This concentration, ideally, you want to generate 5 to 95% larval mortality at the reading time. But sometimes it can be a little bit off, a little bit lower, a little bit higher. But as long as you can cover, let's say 80 or 90% of this range, you should get decent results. So for each and every cup, just do one here is, I will add 100 ml of water to it. This water is tap water, but make it best. You can prepare your water, like put it in the container and sit there for 24 hours in the room temperature to remove the chlorine. So it's safer for the mosquito larvae. Then you're gonna add mosquito larvae. For BTI test, as we know, BTI is very quick acting material. So we use early 4th instead of late 3rd to early 4th. It'll be okay. So we recommend to use a screen. The advantage with the screen is you don't traumatize the larvae. You just touch the water surface, let the larvae swim away. At the same time, you can count, inoculate 25 larvae per 100 ml water. You can control the pace they will swim away from to get it done. And of course, some people use a dropper, but the dropper you have to control the water volume into it to minimize the water volume. You can get one larva have a very small amount, but it can be time consuming, can be a little difficult. So the screen is better. Sometimes you use the finer screen if the larvae on the smaller side, because the bigger screen, some larvae go through. And when you are doing that, you are doing a screening of a larva side, the size of a larvae rather. So after that, you do all these cups for 4 concentrations from low to high, cover the range of 5 to 95% plus your entity control. Then have 3 replications. So typically 15 cups will cover 1 bioassay. And the range, how could you know what concentration will lead 5 to 95% mortality? That based on the literature, based on your experience. On the other hand, if your range does not give you the mortality you want, for example, at the high end, you only get 10% or 20%. That means something going on in your mosquito population. If everything done right, population may show some tolerance or resistance. That's something exciting. That's what you want to find out. So after I've done all the water and the larvae, you make a treatment. So the range we're using from here, you can rate for BTI, for this material, we use the range of 0.01 parts per million, then 0.025 parts per million, then 0.05 parts per million, and the last one is 0.1 parts per million. Of course, entry control, you're not going to put the pesticide to it. So the calculation would be which vial to use, how much add to that cup, which hold 100 ml water, and give you a final concentration of 0.01 parts per million. So it's a simple math, but can be confusing. So the calculation is we need to add 0.001% this 3000 ITU per milligram BTI in the amount of 100 microliter, 250 microliters, 500 microliters, and 1000 microliters or 1 milliliter. As you can see from the range is 0.1 to 1 mil in the 100 mil. That's the range I try to control without consideration of the small amount go to 100 mil. We kind of ignore the difference of the added part to the total volume, the difference before and after. So we still consider it's a 100 mil after this addition of treatment material. After that, you can see this cup, we add some larval food to this assay for a couple reasons. First, the larvae is growing, of course. We know BTI is by ingestion only. So the larvae has to feed in order to be killed. So add this food material will promote their feeding behavior. Of course, if you add too much, it will reduce, too much microbial activity. It may reduce the activity of BTI. So there are certain amount. So what's the amount we believe is best for this system? Is we make 10% suspension of rabbit pellets, or you can measure your water volume and weight of pellets and make it around 10% and soak it for 20 or 30 minutes. Then you stir them up to make a slurry. Then you take the slurry, take the even part possible, then you add it to the cup. Couple of 3 drops for that. Oh, actually 4 drops. Couple of 3 drops. So then after you add that, you can see the cup still, very clear, and it looks like not much going on here with the larvae, water, and the food particles. And after this, you keep this set up under 82, I would say 82 to 85 degree, kind of warm, because mosquito larvae feeding behavior is controlled by water temperature. You keep this set up under this temperature for 24 hours. Then you read your results. We're going to talk about how to read just a little bit. So if you remember earlier, we talked about how to set up the assay. Now is time, 24 hours later, you take a look, you should see the range you're looking for. For example, from low to high, the lowest concentration, you should see a very minimum mortality. Then you have more mortality, even more. And the last concentration, ideally, you should see very few survivors. That means you get a range, a good range for your assay. But sometimes it can be tricky to get this exact range. For example, your first one is no one dead and start from second one. Ideally, you will see a low amount of mortality in lowest treatment concentration, say between 5 and 15. The larval mosquito mortality should increase directly with pesticide concentration across the area of cups and reach high levels of mortality around 85, 90, or 95 in the highest concentration of pesticide being tested. You probably should do the lowest concentration first because your cups and pipette are comparatively clean. You finish all the replicate in the lowest concentration and then you move to the next higher concentration and so on until you count the number of survivors in the highest treatment concentration. You should not see many dead ones in the untreated control. Maybe a couple, 3. If you see more mortality than that, correct for the mortality in the control treatment by using Abbott formula or redo the bioassay. I'd rather redo the bioassay if I have some suspected contamination. Your untreated control, you should not have a noticeable mortality here, which my test here, I do not see any cadavers down to the bottom of the cup. I mean, I almost have a 0 mortality, but I don't know for sure until read. So read larval mortality, you would think it's very easy, dead is dead. But sometimes it can be tricky if it's dead or not, or dying, or not so dead. So for example, the word moribund. They are not able to maintain their normal movement, but they're still alive. And those ones we consider dead. You have to make your criteria, your call. You have to be consistent. So the principle would be you rate your lowest concentration, all 3 replication first. Always start from low because your dropper are going to dip the water from low to high through this 15 cups. You can rate all the replicate in the lowest concentration and score the mortality in each until you count the number of survivors in the highest treatment concentration, where most of the larvae should be dead. The body of the dead larvae typically shrinks in length, darkens, and often sink down to the bottom. You put 25 larvae into each cup. Instead of looking for the dead ones, you count the survivors because surviving larvae can eat the cadavers of dead conspecifics. You blow the water and stir up the water a little bit to see how the larvae respond to your disturbance. Then you pick the ones that are diving, swimming gracefully and respond to the disturbance created by blowing air or touching the larvae with the pipette. The lowest concentration will take longer to count because there are more survivors in each cup than the higher concentration in the bioassay. You collect and count larvae that are alive. For survivors, well, I'm sure this one is 1 larva dead. Then I remove my lowest concentration, finish this 3, then the second 3. So you always collect the survivors all the way through. And after that, you can record, as number of dead or number of survivors. But for the death analysis later on, probably the model only take number exposed versus number dead. So for that convenience, you rather record as number dead. The number you put in is 25. And you can do a quick estimate after you record all this data using this log paper. Your y-axis is probability unit. Label as the probability unit actually is mortality on the converted y-axis. The axis is the logarithm of those. Then the next thing is you want to take a look. you already have a feeling, like I said, if there are too many survivors, your dose is too low. If there's no survivors across the board, your dose is too high. You need to dial up or down the range of doses in the bioassay. If you see the distribution of data points is scattered on the paper, not approximating a straight line, there's greater variability in bioassay data. You may have to decide to repeat your bioassay or just discard data. If the mortality data are scattered, is there any value of this? Of course, they still have a value. You can estimate the line through this data. You can guess next time where your range should be. If you see a nice distribution of the points like this, from your low to high concentration, you see approximately a straight line. That means good data quality. You will then continue with your data analysis using computer. On the other hand, if you plot your data here, the dust jumps so much out of a pattern even, you don't need to bother to analyze the data because very likely the model is going to refuse your data or will try the best to analyze data and give you a very broad confidential interval, which means your data is not dependable. So that's how you read the results of a bioassay testing BTI.